Bismillahirrahmanirrahim. Assalamu alaikum. How are you all students? Today this is the 12th lecture of grade 10. The chapter name is Chemical Equilibrium and the topic name is Equilibrium Constant. First is what is equilibrium constant? Equilibrium constant is the ratio of the product of concentration of the products to the product of concentration of the reactants at equilibrium state. For example, we have a reaction a plus B will give us C plus D. Here C and D are the products. So the product of concentration of the products, that is C plus D, to the products of concentration of the reactants. Reactants are A and B. So the product of A and B, that is reactants at equilibrium state. It means that reactants concentration is equal to the product's concentration. A reactant concentration is at equilibrium with the product concentration. Means the amount of reactant utilized will be equal to the amount of product formed. Now here is an example that 2NO2 will give us K2O4. We will determine the equilibrium constant and the rate constant. In case of the reactants, I write it as K1. In case of the product, I write it as K minus 1. But when I am writing the equilibrium constant expression, I write it as K1 by K minus 1. Means K1 is the forward reaction and K minus 1 is the rate for the reverse reaction, which is equal to N2O4 is the product and NO2 is the reactant, and 2, that is in place of its coefficient, 2 is the concentration of NO2 and 2 is the power of NO2. So the K1 will be the equilibrium constant or rate constant for forward reaction and K minus 1 is the rate constant for the reverse reaction. Now we write it as equilibrium constant expression is equal to product of concentration of the product by concentration of the reactant. Here we don't have two reactants or two products, so we cannot take the product of these. So I am simply defining it as equilibrium constant is equal to the concentration of the products to the concentration of reactants. The value or unit of Kc depends on the equilibrium constant expression for the given reaction. Equilibrium constant K is unitless. What does it mean? That in first case, when Kc has no unit for a reaction in which the number of moles of reactants and products are equal, means the concentration of the reactant and product is equal, it means that there will be no unit of Kc. This is because the concentration units cancel out in the expression of Kc. For example, in the reaction of hydrogen iodide, you know that hydrogen react with iodine to form hydrogen iodide. It means that 2 moles are present in the reactants and the same 2 moles are present in the product. So it means that number of moles of reactants and products are equal. It means that there is no unit of Kc. All the units will cancel each other. In the second case, when Kc has units for a reaction in which the number of moles of products is greater than the reactants in a balanced chemical equation. If the number of moles of products are greater, then we will have a unit for Kc. For example, N2O4 will give us 2NO2. N2O4 means this is 1 mole of N2O4. While in the product we have 2NO2 means 2 moles of NO2, which means that the product contains 2 moles. So the number of moles of products are greater as compared to the reactants, so the Kc must have a unit that is mole per dm3. In the third case, Kc has units for a reaction in which the number of moles of product is less than the number of reactants in a balanced chemical equation, or the number of moles of the products is greater than that of the product. The number of moles of reactant is greater than that of the product in a balanced chemical equation. For example, in the formation of ammonia, 1 mole of nitrogen and 3 moles of hydrogen react to form 2 moles of ammonia. It means that in the reactants we have total of 4 moles of ammonia, while in product we have 2 moles of ammonia. So by writing the value of Kc, the unit of Kc will be 1 by mole per dm cube whole square. So in case of equal number of reactants and products, Kc will have no unit. In case of number of moles of products greater than the number of moles of reactants, Kc will have a unit. In case number of moles of reactants are greater than the number of moles of product, Kc will also have a unit. Why is the value for K unit less? Each concentration in the equilibrium constant expression is divided by a standard concentration of 1.0 molar. So each concentration in the equilibrium constant expression, that is C, D, A and B, is divided by a standard concentration of 1.0 molar. Here is an example. Yesterday we have discussed these example as well. So what is the value of K when the concentration of NO2 at equilibrium is 0.0165 molar and the concentration of N2O4 is 0.0417 molar. So the NO2 concentration we know and N2O4 we know the concentration. The equilibrium NO2 concentration is 0.0165 molar and the N2O4 is 0.0417 molar. Now we have to put the values in the equilibrium constant expression, that is K, which is equal to the concentration of the product by the concentration of the reactant raised to the power of concentration, is equal to, write the value of concentration of N2O4, which is equal to 0.0417 divided by the concentration of NO2, that is 0.0165 into power of concentration, which is equal to 153. This was all about equilibrium constant and the rate constant. Thank you so much.